So I've got all the formulas out there. We have our distance formula, that's your D. Your midpoint formula between 2 points. The standard circle formula that you're used to, the HK being the center, the R being the radius. And then the general circle formula is what you spent time on last year, completing the square and translating it back into the standard circle formula. So we'll do that again to refresh that. But this should definitely mostly be review. First example, pretty cut and dry. They're giving you the center, they're giving the radius, they're asking you just to appropriately plug in and write the equation of the circle in standard form. So you're just going to plug in your H, x minus negative 2 squared plus y minus your k of 3 equals your r squared, so your 4 squared. And your double negative just becomes plus. Joseph.
Would they want us to write 15 or leave it as 4 squared?
They would want you to simplify, so write it as 16.
Okay.
Yeah. Then just quick little sketching for circles. So x minus 2 squared plus y plus 4 squared equals 9. What is the center, Sam? 2, negative 4. So he obviously recalls the fact that whatever number you see, if you see negative 2, it's actually a center at 2. If you see a positive 4, it's actually a center at negative 4. And a radius of what, Mackenzie? 3. So I think the best way to sketch this is obviously to start with the center. And forgive my rough sketch of coordinate axes. And then from there, you count out 3 units up, down, left, right, and then just sort of sketch it. So 3 up, 3 to the right, 3 to the left, 3 down. Can't really, and there you really can tell how my sketch is off because that's a little far. But you can't count 3 diagonally, unfortunately, so you just have to go north, south, east, west, and then you're going to sketch it from there. Okay, what is the domain of this? Aniela? -1 to 5, and I'm using brackets because it actually reaches -1 and it actually reaches 5. And the range, Haley?
-7 to -1.
Good.
So the range comes right to the lower one, 4.
For always interval notation in general, you always start with the smaller to the bigger. Anything else? Okay. So then the review of completing the square to convert. So the first thing you want to do is rearrange your polynomial so that your x's are next to your x's, so x squared plus 4x. And then your y's are next to your y's, so plus y squared minus 6y. And then get rid of your negative 23, add that over. Any constant you want to get rid of. We're going to complete the square on the x's. Christian, do you remember how you complete the square on the x's right there?
Take
half of 4 and square, correct. So that's half of what is typically considered your b term, and you square it, and that's what you add to both sides. So half of 4 is 2, and then 2 squared is 4. So we're going to add a 4 here, and add a 4 to the right-hand side of the equation to keep all things equal. And then on the y's, what are we going to add to both sides? Hannah Webb? 9. Half of -6 is -3, squared is 9. So what we just did on the left-hand side is we completed a trinomial. We made it so that this trinomial was a perfect square. In other words, it can be written as some binomial times itself. What is that binomial? X plus 2, very good. And for the y's? Y minus 3. So that's just factoring, but we made them a perfect square trinomial so that they would factor into something times itself so that we could write it as something squared. And then 23 plus 4 plus 9 is just 36. So once we're in that format, we know that our center is, Lauren, what? Good. And our radius, Joe? Good. One quick thing to add about circles. It didn't happen in this particular one, but if your x squared and y squared have, let's say, a coefficient of 2, okay? You don't complete the square until you've divided everything by 2. Does that make sense? They cannot have a coefficient before you complete the square. You'd have to divide that coefficient away. Secondly, if they're not the same coefficient, then it's not a circle. Does anybody know what it would be? Like if it was 5x squared plus 4x plus 3y squared, and they were different coefficients, that would not be a circle. Does anybody know what it would be? What'd you say? An ellipse, right? Kind of an off circle, like your ovals. Or sometimes they're oblong this way. But when they're the same coefficient, if it was like 3x squared, 3y squared, now it's a very balanced round thing and it's a circle.
So if it was 3x squared and 3y squared, would it be, like, would you reduce it?
It would still be a circle, but we would have had to, before we did any of this plus 4 plus 9, we would have had to divide the 3 away, divide by 3, divide by 3, divide by 3, divide by 3, and then change it into x squared plus y squared.
Okay.
Tori?
If you do have a coefficient on the x and y, and if you plan to 3, is that what does it do? Does it make it like the radius bigger?
I think it's going to make it smaller. So think about this. If I kind of went backwards.
So if it was like a number less than 1, it would make it bigger. If it was number greater than 1, it would make it smaller.
Let's say I do a 5. If I multiply everything here by 5, I actually don't think it does anything to your circle, now that I think about it. So if I'm just multiplying all of these by 5 to kind of think this through. It's a great question. Negative 115 equals 0. If I divide both sides by 5, it's still the same equation.
Yeah. What if, like, the other numbers did change though with them? You know what I mean?
Did not change with them.
Yeah, like instead of multiplying everything. Like
So if I kept this a 4x,
yeah, then it would make it smaller.
then, that's a good question, minus 6y equals minus 23. I gotta think this through. Seems like it would. That would be my gut, but I would want to...
Like the radius would be divided by 5.
Yeah, so if I divided everything by 5, I mean, it's going to be ugly because these numbers are not great, but yeah, it's going to make, obviously that's now a smaller number to start, and when I take half of b, half of 4/5, and square it, I'm also adding a smaller number over. So it's going to shrink it. It's also going to affect where the center is. So rather than the center being at negative 2, I think it's going to be at negative 2/5. So what did that do? It kind of compressed it in a little bit. So it's going to do a couple things. That's a good question. Yep.
When you when you divide out the 5, where does it go? Like,
You're taking an equation and you're just dividing both sides by the same number. It doesn't go anywhere.
Wow.
It's no different
so
than...
like you don't have to put it in front of
Like factor it out?
Yeah.
No, because it's an equation.
Oh, okay.
And when anything's an equation, you're allowed to do the same thing to both sides and just let it disappear.
Oh,
Okay? Versus if it was an expression without the equal sign and it was just rewrite it and factor it, that would be a different set of directions. You would have to track that. Yep.
Are there circle, like, transformations?
Yeah, so this particular circle, here's your parent graph is x squared plus y squared. So center at 0, 0. This has been shifted left 2 units,
Oh, okay.
right?
Like transformation itself.
And up 3, yep.
Okay.
Yep. So it's a little bit different because this y minus 3 is occurring to the y, so it's a vertical movement. But because it's in this set of parentheses, kind of like when you're doing horizontal movements and things are backwards, this is backwards. This actually means up 3 as opposed to down 3. So we don't really include this in our parent graph because A, it's not a function. And so it works a little bit differently, but it is, there are those ideas wrapped up. This is shifted left 2, which is consistent with your functions. But this, it would actually be a shift up 3. Okay? Anything else? All good questions? Okay. So the next example here is just asking us to graph this circle on a graphing calculator, which I just want us to kind of wrap our heads around how this would have to work. Because our calculators don't straightforwardly graph non-functions. So they don't just graph circles. So how would we go about seeing the circle on our calculator, Nick?
Graph 2 different functions.
Right. Graph 2 different functions. One's going to be the top half of a semicircle, or top half of the circle, and the other is going to be the bottom half. Okay? So what do we always have to solve for if we want to graph it using our calculator? Y. So the first thing I'm going to do, let's talk about that. What do you have to do first to start getting y all by itself? Correct. Subtract this term over. Don't do too much work. You don't need to multiply anything out. Just literally subtract this x plus 2 in parentheses squared. Then what? Square root both sides. What do we have to remember to do here? Plus or minus the square root. What happened?
I said, oh, she's on a roll.
She's on a roll. And then, Kristen, add your 3 over. So kind of like you would do in the format for the quadratic formula, when you add your 3 over, you want to usually put that in front of the plus or minus. So your positive 3 plus or minus this whole square root bit. And then we type in 2 separate functions. 3 plus the square root. And then 3 minus the square root. And then graph it. Yeah, let's talk about that. First of all, well, what's your window? Crazy?
Yeah.
If your window's crazy, it's probably set at whatever it was left off at from your previous use. Just hit zoom 6, and that'll put everyone on the standard negative 10 to 10, negative 10 to 10. Still kind of looks like an oval, though.
Yeah.
Why? How could you explain why it looks like an oval? This is kind of like a non-math answer. Sort of. I guess you could argue it's math, Joseph.
The distance between the, like, lines on the y-axis is closer than on the x-axis.
Correct. And generally speaking, it's because our window is set up to be a square, but it's being graphed on a rectangular screen. Right? So because it's a rectangle and this distance is further, even though we're going negative 10 to 10, that's a little more stretched out, then your negative 10 to 10 would be going this way because your graph isn't as tall as your screen isn't as tall as it is wide. But it is a circle. What else is of interest or kind of like a little bit weird about your circle? Yeah, those gaps. This is not because there really truly is a gap there. There is not a gap there. I know it looks like there is, and that's just a pixel error kind of thing. The quality of the screen on your calculator is not that of your TV at home, so it's not going to be perfect. Think of like computers when they first came out 20 years before you were born, and the pixels were just terrible. Just to confirm, what would this point be? Think about that. What should that point be on the leftmost point on the circle? If the center is at negative 2, 3, and the radius is 6, where should that point be? Negative 8, 3, very good. And you can just confirm from your graph that if you plug in negative 8, you're going to get negative 8 plus 2 is? Negative 6 squared is? 36 minus 36? Square root of 0. 3 plus 0. Okay, so if you plug in negative 8, you should get the point 3. It just doesn't show. But if you do want to zoom in, like if I hit zoom and my option zoom in, and I bring my cursor, which is currently at the origin, you can't even see it. If I bring this up and over and zoom in over here, and get closer, you're going to see it much more closely, okay? Again, still showing the gap, but you could keep zooming in there. And that's just the pixel error causing that gap. It's not really supposed to be there, okay? Any questions on that? And then zoom 6 brings you back. Okay, last and probably least, to be honest. We're not going to do too much with the distance formula this year. The distance between 2 points, you're just stealing from your formula. y2 minus y1 is 4 minus 6, square that, plus x2 minus x1 is 5 minus 3, squared. Negative 2 squared is 4, plus positive 2 squared is 4. You get root 8, which reduces to 2 root 2. So your distance between those 2 points is 2 root 2. And your midpoint formula, you're just x1 plus x2 divided by 2. And y1 plus y2 divided by 2 gives us 4, 5. Out of curiosity, where does the distance formula come from? Like someone was just a genius and made up the formula, or let's look at a graph. If I were sketching and put 2 random points, I don't know, this one's going to be my first point, x1, y1, and this one is going to be my second one, x2, y2. And we want to find the distance between them, the length of that segment. What do you think, Nick? Yes. So this is the distance we're looking for, agreed? Okay. We can count horizontally and we can count vertically, right? So the length of this side going from the first x-coordinate to the second x-coordinate, the length of this side is x2 minus x1, agreed? So that is a length of x2 minus x1. This is a length going from the second y coordinate to the first y coordinate, so the difference between those. So that's y2 minus y1. And if you set up your Pythagorean theorem, you would have this side squared, x2 minus x1, that side squared, plus your other leg squared, equals what? A squared plus b squared equals c squared, and our hypotenuse in this case I just labeled d for distance. Then if you want to get the distance all by itself, you take the square root of both sides. So d would equal x2 minus x1 squared plus y2 minus y1 squared. And why don't I use a plus or minus?
Because it gives you the radical? Yeah.
No, I don't know what you said. Can't have a negative distance, so just by the sake of what distance is. Okay, now out of curiosity, because why wouldn't you be curious? Where does the midpoint formula come from?
Average.
Average, right. Middle, average. So if you want the average x-coordinate, you take the average of 3 and 5. Halfway between 3 and 5, aka the average of 3 and 5, is 4. You just take the average of them. You add them up and divide them by 2. 6 and 4, same thing. You want to find the average, meaning halfway in between. So for example, if I went back to this same problem, and I wanted the midpoint of that D segment, I would want to find halfway between these two x-coordinates. So you just average them together to get in the middle there. And then for the y-coordinates, same thing, you just average them together to get in the middle, so it would be somewhere here. Okie doke? Alright, so there's your homework. We're all done.